Well, I think we can be very proud of the contribution that we make to particle physics in general and to this particular experiment at the Large Hadron Collider in particular. So it's great that Britain is involved, and we have a long record of scientific experiment. As to kind of what we get out of it, apart from just fulfilling intellectual curiosity, which is a pretty important thing in itself, well, the Large Hadron Collider has already led to Tim Berners-Lee and the development of the internet, which is a pretty big thing, and also some of the precision that we've got from the Large Hadron Collider has made the refinement of GPS possible. So there's some big applications already. Nobody can claim to be for sure. Nobody can claim to know for sure what future applications there may be, but I'm sure there will be many important applications in the future.
And another role, I guess, for things like the Large Hadron Collider is the inspirational value in terms of encouraging young people to take up science.
Oh yeah, if the Americans still talk about what they call the Apollo effect, everybody following the Apollo missions then wanting to study science and technology at university and get involved. Similarly, the excitement surrounding the turning on of the Large Hadron Collider was immense. I happened to be the privilege here in London of being directly on a video link to what was happening at the labs. But the excitement then, the media coverage, I think really got people interested. And when we've got big scientific experiments like this, it's a great opportunity to capture young people's imagination and get them involved in science.
Now, some people are a bit sceptical about blue sky research. Obviously, it's great, as you've said, in terms of inspiring people. But what other value does particle physics bring to the UK?
Well, first of all, blue sky research is valuable in its own right, and we shouldn't be embarrassed about that. But clearly, as well, nowadays, there are potential applications down the track that nobody can know for sure what they are. But immediately, you have this fascinating interaction of science and technology. Often scientific experiment is only possible because of advances in technology, and in turn drives advances in technology. So you need new technologies for the particle physicists or other groups of scientists to carry out their experiments. And then you discover that something you're using to measure large data sets generated from the Large Hadron Collider is kind of useful in neuroscience for recording activities across many brain cells, whatever. You find there are strange parallels. I'm told something in the Atlas experiment has proved to be very important in understanding the workings of the eye. So some of the technologies that have been developed at the Large Hadron Collider are already proving very relevant in other parts of the economy.
And in terms of the UK expertise, do you think people underestimate the value of how big particle physics is for UK physicists?
Well, when I went there, it was striking how many Brits were involved in the scientific experiments, in designing them and monitoring them. Yeah, so we do really play a big role in science around the world, and we should be proud of that. And that's what historically we've done. We're very proud of those traditions. We should never take them for granted. We've got to keep on world class, and I think we can be.
And obviously, once the Higgs is discovered, which we assume it will be, what do you think is next in terms of the next step for particle physics beyond that?
Well, first of all, I'm just the science minister. I am not a particle physicist, and I don't claim to be sure whether or not the Higgs boson is going to be discovered. I think there's a kind of expectation that will be, but my view about whether it's going to be discovered or not is of very little value indeed. But I hope that even if the Higgs boson is discovered, which does confirm some aspects of the standard model, I'm sure there will be other intellectual challenges that physicists will still face. And because it's the endless, relentless curiosity that has got us this far, and it's not suddenly going to be turned off with this experiment, it's going to carry on way into the future.
And I guess one of the aspects of that is the knowledge exchange. Obviously, we make these discoveries, we learn more about the Higgs, but then we need to keep passing the knowledge on so that future generations can keep that search for knowledge going.
Well, I may not be a physical scientist, but I am certainly very interested in the principles of fairness between the generations, really, is what I've written a book about. And I think it's a very powerful argument that we are the beneficiaries of the science and technology generated by previous generations, and we have a similar obligation to improve our understanding of the world and widen the range of technologies we've got available to pass something more on to generations coming after us. And we must certainly, all of us, play our part in that, and I think we are.